Slope-intercept form is what we're studying today. We're going to be able to recognize and write equations in slope-intercept form, whether it's from a graph or if I give you 2 points. So parent function is the simplest form of a function. Linear equation is an equation that models a linear situation. This whole chapter we're just sticking to linear functions. Last chapter we actually graphed some other types of nonlinear functions, but these just linear. We'll learn some shortcuts today for graphing lines, so you don't have to do an entire table. The lines will be of the form y equals x is the parent graph. We're going to have a y-intercept added onto that. The y-intercept of a graph is the y-coordinate of the point that crosses the y-axis. So it's just the y-coordinate. We're just going to list a single number of the point that crosses the y-axis. So we have a linear equation right below that definition. And that linear equation has a y-intercept. I think you can read it off the graph, maybe better off of your packet. But can you tell me what the y-intercept is for this graph right here? What is it? 4 is the yes. 4 is the y-intercept. So the form of the equation of a line we're studying today in today's lesson is y equals mx plus b. It's probably the most widely used one. If you were to graph this on a graphing calculator, which you'll eventually get the privilege of being able to do. Not in this class. Well, maybe you might try it in here just for fun. But our focus in here is to be able to do this analytically or by hand. But you would enter it in that form, y equals mx plus b form. So it's like the graphing form. Quick graphing form. This particular example is a negative sloping line. It's got a y-intercept of 4. You'll notice there's a 4 right here in the position of B. And then it's got a slope of, if I count, 1, 2 down and 1, 2, 3 over. If I go from this point right here down 2 units and right 3 units to this point, I get a slope of -2/3. And you just plug those in for the m and for the b. That's it. So when you're given the picture of the equation of a line, or a graph, the equation of a line, you can use the graph to identify your y-intercept, which is 4, and your slope, which is -2/3. All right. So you're going to be asked in your classwork just to identify the slope and y-intercept. If it's okay with you, I'd like to, instead of writing slope, could we just use m for slope? Are you okay with that? So we use the letter m for slope. On this first one, I'll write this down so we know slope is equal to m is equal to 5 on this one. Okay, so it's the number in front of x is your slope. If you were asked to graph this, you would be thinking of the slope as 5 over 1. Okay, because then you would have a vertical rise number of 5 and a horizontal run number of 1. We don't want to go from the y-intercept and go up 5 and then stop. We need to also go right 1. So slope is 5. Some students will write it as 5 over 1. But it's okay to just write m equals 5. You just need to understand that there is an unwritten 1 underneath that 5. And that will be used when we graph it. The y-intercept, we use the letter b for that, and the y-intercept is -2. We need to understand that the coordinate of the y-intercept is actually 0, -2, but if you're just asked to identify the y-intercept in this equation, I'm okay with you just writing down -2. Second one, what is m? -3. What is b? 1. And that's all you're going to do in this first couple of problems in the classwork. Just identify them. What about this one? M is, and b is the tricky one here. B is not there, so it must be 0. Yeah. That's a direct variation equation there. So what are the slope and y-intercept of the graph of y equals negative 1/2 x plus 2/3? What's m? Negative 1/2, and b is 2/3. And if you were to take, it says how did the graph of the line and the equation change if the y-intercept is moved down 3? I could show you visually what that would look like if I go back to the sample problem here. If I were to take this line and move it down 1, 2, 3 units, keeping the same slope, you'd have a new y-intercept of 1 instead of 4. The slope wouldn't change, but all the points would move down 3 units. That's it. So that's what it was asking in that one there. So how did the graph of the line and the equation change if the y-intercept is moved down 3? The entire line moves down 3, keeping the same slope. So the entire line moves down 3, keeping the same slope. We're going to be asked to go the other direction. If I give you the slope, which is negative 4/5, we'd label that m, and the y-intercept, which is 7, label that b. What's the equation of the line? It's just y equals, remember it's mx plus b. I'm going to rewrite it here. And we're going to fill in negative 4/5 for m and 7 for b, and that's it. That's all we're looking for, just plug in the m and the b. That's the easiest scenario there. Second easiest is if I give you the graph of it, and then the more difficult one is if I give you the 2 points, and we'll go over that last. So what's the equation of the line with slope 3/2 and y-intercept negative 1? Can you tell me what that is? That's right. 2x minus 1. So there are a couple of problems like this on your classwork, but 2 of each. 2 like problem 1, 2 like problem 2. All right. Write an equation from a graph. It says, what is the equation that represents the line in the graph? So this is like my first example I did like that. We've got to find b. The b here is right here. So we could say b equals negative 2. Here it is. It's right on the graph. To get my slope, I'm going to read it off the graph like I did in the last lesson, like we did for homework. From that point, if I go from there up to here, I'm going up 2 and over 1, right? So the slope is equal to 2 over 1, or just 2. So the slope is 2 over 1, or just 2. I go up 2 and then over 1. You need to make sure that you choose 2 points that are on the intersection of grid lines, like what you see here. There's the intersection of grid lines right there. So oftentimes they'll give you 2 points if they want you to compare those, use those 2 points to get the slope. So when I go to plug this in, I've got y equals m is 2, x, and then minus 2, and that's it. So just right from the graph. See if we can get the equation from the graph. So look at the now you try one. See if you can pick out what the slope is. What do you think the slope is on that? Can you tell? What is it? 1. And it is negative 1 because it's going down from left to right. And then b, can you read it off of there? 2. Yeah, I just got to be aware of the scale and how they have it. So it's y equals negative 1x plus 2. The way they'll write this is just negative x plus 2. Like if you're in a multiple choice test or whatever, they won't write the negative 1 in front of it. Both are correct. The negative x plus 2 is how it'll be written. Does the equation of the line change if you count the slope from different points? No. I mean, I could count it from here to here as a slope of negative 1, or I could look at it and compare from here to here. Then it's just negative 3 over 3, which is still negative 1. So it doesn't matter. The slope shouldn't be changing. No. All right, and then this is the most labor-intensive one. I'm going to go through the steps on this. it's really not that bad. I'm going to show you all the steps. A lot of this can be done mentally in your head. Okay, so arithmetic with integers is good, or if you have a calculator at your disposal. But here, I want to get it into this form, right? mx plus b. Now, here's the thing. They didn't give me n, nor did they give me b. I have to find both of them. So how do I find m? This goes back to last lesson, right? Do you remember the equation we need for finding m? Yep, minus the y's, minus the x's. So you have to do that. So it's m equals, let's call this x1, y1, and this x2, y2. So it'd be negative 8 minus 1 over 5 minus 2. I'm going to simplify that, negative 9 over 3, which is negative 3. So now I have n. They didn't give it to me directly, but I've got it. So here's what I have so far. Y equals negative 3x plus b. Now, to do what I did in the previous two sample problems, I need to figure out what b is. They don't tell me what b is. They don't even have a coordinate that has an x of 0. If they had like 0, 7 is one of the coordinates, then b would be 7. But neither one of these points has a 0 as its x coordinate, so I've got to figure out b. I could figure out b if I knew an x and a y to plug in here. Like, I can't handle this with 3 letters in it, but I could solve for b if I knew an x and a y. Well, the truth of the matter is I have 2 x's and 2 y's to choose from. Right? I could pick one of these points on the line and plug them in. Now, that kind of warrants the discussion, which of those 2 points do you think would be easier to plug into this equation and solve for b? Yeah, I think so too. The 2, 1, not only because they are smaller numbers than the 5 and the negative 8, but they are also both positive. So it's your choice. You could choose either one. You'll get the same results. But I would probably choose 2, 1. And so the 1 is the y. Usually what I do, just to make sure I don't mix it up, is I plug in I locate the y, and I put it in right here first. So put the y in for, or the 1 in for y. So we've got 1 equals negative 3 times 2 plus b, and what I notice is that I have everything I need to solve for b. In other words, this is going to tell me where the equation of the line is going to cross through the y-axis. I'll show you another way to think about that too, but let's finish this up algebraically. We've got 1 equals negative 6 plus b. If I add 6 over, I get b equals 7. So add 6 to each side, b equals 7. So here's what I've got. Final answer. I've got to take this guy right here in green and rewrite it. It's y equals negative 3x. Now I know what b is, so I put it into the equation, plus 7. I think you'll get to a point where you could probably calculate the slope all in your head. So there's, half the work on here is calculating the slope. Then the other half is plugging in a point you may have to write down. So here's what we were actually doing here, just to show you what's going on. I'll draw a little graph. If I'm at 1, 2, 1 right here, if I were at 2, 1, I'm not going to go to 5, negative 8 because it's way the heck down here on the right. But if I were at 2, 1 and I have a slope of negative 3, that would mean I'm going up 1, 2, 3 and over 1. So I'd go up 3 and over 1, and then I'd go up 1, 2, 3 more and over 1 more. And if I were to keep doing that slope from the point 2, 1, I would eventually cross through at 0, 7. So that's a more like a visual way to see what we're doing. When we plug in the point 2, 1, we're finding out if that line were to continue through the 2, 1 and keep going at a slope of up 3, left 1, up 3, left 1, which is negative 3, it would eventually hit the y-axis at 0, 7. So it's a visual representation of what we're doing. See if you can find the equation of the line through 3, negative 2 and 1, negative 3. Go ahead and calculate the slope first. So this is step 1 right here. Calculate the slope. Just give you another 30 seconds on that, and then I'm going to ask for a slope. if we're in agreement. It's easy to make an error on the slope. Don't worry about it. They all make errors on it. It's easy to make a sign error. Check with each other. Skip problem 5. What do you guys get for slope on this? Are you willing to throw it out there? Yeah, Abby, did you get 1/2? You guys, anybody else get 1/2? Yeah. So, good. M equals 1/2. So it's tricky sometimes with all the negatives and stuff. But good. We got that our slope is 1/2. This one's a little more difficult than the one I just did. What I have so far, I'll write it in green. We're at this step. Y equals 1/2 x plus b. Okay, so we're at this step right there that you see up above in green. What do we do next after we get the slope and pop it in for m? Can you tell what I did next up here in blue? Is it not clear? I need to find b. We're going to do some wishful thinking. I need to find b. I wish x and y, there are numbers I could put in for x and y. Are there any numbers in this problem I could put in for x and y? What are they? I could plug in -3. I could plug in 1. I could plug in -3 for y and 1 for x. Unfortunately, neither of them are even. Like, I wish one of these had an x-coordinate that was an even number, so then I could take 1/2 of the even number and I'd be back at a whole number. It doesn't. This is going to come out as a fraction. As a matter of fact, on your classwork, I want you to do 24 instead of 22. So your pink sheet, if you have it handy. Cross out 22 and do 24. I want you to do one with a fraction. To be honest with you, in real life, most of the time slopes are decimals or fractions, and most, y-intercepts are not going to be whole numbers. Okay, so it's good to be able to deal with these fractions. Here's what this will look like. If I take the suggestion that we use 1 for x and -3 for y, I think that's a good one. We'll put -3 in for y, 1/2 of 1 plus b. So I just plug in my point. And now I've got to solve for b. So I've got -3 equals 1/2 plus b. I like to just leave it as a mixed number. Don't change it to an improper fraction till the very end. It's a good idea to change it to an improper fraction because that will match the form of the slope that you see here. Okay, the slope will always be a ratio of two numbers. And so, if you're doing a multiple choice question, you're taking some kind of a standardized test, that's probably how the y-intercept will be written. But if I were to graph this line, I'd want it as a mixed number. Because you tell me to go graph 15/2, I'm going, well, I'm going to change that to 7.5 to go graph it. So then I know it's halfway between 7 and 8. Like, I'm going to, in my mind, change it to a mixed number, right? So here, if I subtract 1/2 from each side, -1/2, -1/2, I've got -3.5 equals b. When I rewrite this up here, I'm going to rewrite it as y equals 1/2 x minus, I'm not going to write 3.5. I could, that'd be okay, but I'm going to change it back to an improper fraction. 3 times 2 is 6, plus 1 is 7/2. This is how you'll see it written. So I'd like you to change it back to an improper fraction. Just write it that way, 7/2. If I were to graph it, I would think of that 7/2 as 3.5. Okay. And this last problem here, didn't show up. Let's see here. Oh, it's not the last one yet. We're almost to the last one. This is going the other direction. So instead of giving you the graph and asking you to write the equation, here's the equation. What's the graph look like? The y-intercept we sometimes call the starting point. It's not really the starting point. It's not really the starting point because the line goes forever in each direction. But if I'm going to start anywhere, I think the easiest place to start would be at the y-intercept. So I just place a dot right at -1 on the y-axis. Okay, so treat that y-intercept like a starting point. And then this is our slope. And our slope, we want to think of it as 2/1 so that we know the vertical rise and the horizontal run. So I'm going to go up 2 and right 1. and up 2 and right 1, up 2, right 1. I could equivalently go down 2 and left 1, down 2 and left 1. It's like doing a negative over a negative is a positive, and then draw in my line. So either use a straight edge or get plenty of points like I just did, and then you can accurately graph your line. So starting at -1, I go up 2 and right 1. You could probably draw the graph fairly accurately through these 2 points, but what you'll notice is if you have 2 points that are close together and you try to freehand draw the graph, as you go farther away from those 2 points, it gets more and more out of whack. So really easy to just keep going up 2 over 1 or down 2 left 1. We're going to use this method in our next unit on systems of equations so that we have accurate graphs and can tell where the 2 lines cross. Where do I start here on this? Now you try one. -3x plus 4. Where do I put my dot? Right at 4 on the y-axis. Some students will want to put it on the x-axis, but we don't. This is the y-intercept. Put a 4 right there. What's my slope? -3 over 1. So what does that tell me to do from the starting point? Yep, down 3, right 1 to work. 1, 2, 3. And I'm not even going to bother going up 3 and left 1 because that'll take me right off the graphing grid. So 1, 2, 3 down and 1 over. 1, 2, 3 down, 1 over. And I could probably freehand that fairly well with those dots on it. Try this one on your own. You can graph it on your own. And check your answer with mine. So hopefully you got a positive sloping line that looks like that. All right, we're going to skip this one. This doesn't show up on yours. This is about a diver. We'll just do the now you try as our example for this guy. Just skip that one above. This is a plumber charges a $65 fee for a repair plus $35 per hour. So we've got a y-intercept in here. The $65 fee is the y-intercept. The $35 per hour is the slope. When you see that per something, it's referencing a rate of change, which is the slope. So my equation would be y equals 35x plus 65. So we've already written equations like that. Now we're just connecting it to slope and y-intercept. So the y-intercept would be 65. I've got to estimate it on this graph because it's going by 50s. If I were to plug in 1 here, 35 times 1 is 35 plus 65 is 100. So I'm at 1 comma 100. If I plugged in 2, if I had them work for 2 hours, it'd be $70 plus 65, which is $135. And if it were 3 hours, it would be $105 plus 65, which is $170. Which would be about right here. Plugged in 4 hours, be $140 plus 65, which is just over $200. $205. It's probably good enough. So there's my graph. My slope is $35 per 1 hour, and the starting amount is 65. In other words, if he just shows up at my house, I got to pay 65 bucks whether he fixes anything. Just 65 bucks to come out. So, in terms of a summary, the summary is just getting used to the equation y equals mx plus b. This is the slope, and this is the y-intercept. And I could give those to you directly. Ultimately, you need to be able to find the equation of the line in that form if I give you 2 points. That's like the hardest sample. I'd like you to try some just in the next, see if we can do it in the next 12 minutes. I think you can finish the classwork in less than 15 minutes. So there's about 2 of each type on there. I'd like you to do 24 instead of 22 so you get a little experience with some fractions. So let's go ahead and do that. We're not going to do it in groups in here. And I'll show you this little video, and show you a video of a real life scenario of a slope and linear equations. We'll do that when you're done.